Soil profiles, the result of soil development. Here is a fully developed soil profile showing all the possible layers, although layers do not always exist. But here we see the organic layer. The topsoil in this is called the A horizon, and it's where the organic matter mixes with mineral. As water flows through the system, it washes things down. Here, eluviated means things are exiting, and they go down and they collect at the B horizon. So in a fully developed soil, the water comes down and washes things down, 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 and they collect at the B horizon. The C horizon and the rock, that's what the soil is made of. Here's a very simplified soil horizon, something you might see around Sitka. Our soils are relatively young. We had a volcano 5,000, 8,000 years ago. So relatively simplified soils of an organic layer, an A horizon where it's mixed, where organic and mineral soil is mixed together. And then things are washed down into the B horizon, out of the A horizon, and collected at the B. And if we look further down, we see the volcanic ash, or the parent material. Look at that big A horizon. A and B horizon, you might call it. The A horizon all with the organic matter mixed with the mineral soil. Good looking soil right there. Here's a picture of a soil I found on the internet. And this is very important to us because we might have glacial till or river rocks down below, or ocean sand. And then we have a layer of volcanic ash. And then the soil builds up and develops above that. But it's, as you see here, there's a very undeveloped soil. This would call it an entosoil, recent. The soil formation facts: organisms, topography, time, climate, and something. Parent material, what the soil is made of. Three basic classes in soils, depending on if you're in a desert, where it's very dry. And the unique thing about desert soil is when it rains, it evaporates back up out of the surface. So the water comes down and back up. And so it accumulates saltiness at the top, and very basic soils, very non-acidic. Here in a temperate zone, we are in temperate. This is where we have the best accumulation of humus accumulates. We get all the layers going. There's a really exaggerated eluviated zone where it's all white and it accumulates down here, but very distinct layers and very deep soils. If it gets too wet and too hot, everything decomposes almost immediately. Notice there's no big organic matter. There's no big organic component in the mineral soils of the tropic. It's all eaten up by the decomposers. This is one of my favorite depictions of organic development of soils and how soil developments. We start with an entosoil, recent. It's a brand new mudslide, or the glaciers receded. It's just parent material. Then, depending upon the conditions, we travel down this graph to more and more development and time. As time goes on, we develop, and it's weathered. And here in the United States, we have a lot of alpha sols if it's very moist, But our best soils in the world are the mollisols, semi-arid to moist. We'll talk about all these different conditions. This is a map of the soil orders of the United States. We're certainly not going to get in too much detail, but the general look of the East Coast being alpha sols, the Midwest being mollisols, and then the West is more dependent upon the mountains and the extreme weather. But these mollisols, the rich black mollisols, are the best soils in the world. Here's a global map, and starting to get an idea of where the good soils are. Again, there's our mollisols, rich black dirt. And then other places in the earth is this green, rich black dirt running through the through Asia and Russia. This is very excellent soils, excellent soils. All those dark green. The yellow is pretty good of the northeastern, and then as we get into the south, those are good too, but they're more oxidized and weathered soils, and older and washed out. As we look at the Amazon rainforest, look at that. It's not the best soils. It's not rich black mollisols, but it is weathered soils, highly weathered soils. Well, all the organic matter has been decomposed and washed away and back into the earth, back into the atmosphere. Oh, we have simplified orders here. This is a good slide to refer to how the different soil orders, and I'm not going to require that we learn all the different ones, but we want to learn that soil develops differently in different places. Here's permafrost, goes to those type of Gila soils. Organic soil, if it's all organic like then it's a histosol. It's like the muskegs, completely histic. That means organic. And we have forest soils with subsurface accumulation. We actually have spotosols with our acid forest soils. Volcanic ash, andosol. That's only when the volcanic ash is extremely young. It transfers into other soils as soon as organic matter has created more layers. Oxisols, very oxidized. Vertisols, those are interesting soils that crack in the summertime and the top soil falls into the cracks vertically. Arid sols, you probably guessed that, arid for deserts. The ultisols are very leached. A lot of rain over many centuries, many millions of years. And here it is, the mollisols, rich black mollisols under the grasslands. Alpha sols, which is most of our eastern United States, not bad. It's a soil development. And then inceptisols is very young. We might call some of our soils inceptisols because they're so young. Entosols is brand new. Inceptisols is just a little bit of development. Here's another depiction of the different soil orders. And it has the Gila soils, the very cold soils up here, the permafrost soils, and the histosols like the muskegs. Those are kind of different categories. But here, the very young, very little development, and then just a little bit of development. And then we have our different categories over here, depending on how much water and how much heat.